This problem says find the limit if it exists, and the function is the limit as x approaches 1 of x squared minus x over 2x squared plus 5x minus 7. And so the function doesn't have to exist at 1 for a limit to exist for the function as x approaches 1. But you'll notice if we plug in x equals 1, the function comes out to 0 over 0, which is undefined. So this function is undefined right at x equals 1. So we have to figure out a way to evaluate this as x approaches 1. So for polynomial problems like this, the goal is to find common factors to cancel out the one that makes a 0 in the denominator. And clearly the one to factor out in a problem like this is to find out how to cancel out a 1. So if you have a function like this, so if you have this function, but the problem is that when x is a g of a equals 0, this is a problem because then the function is undefined right at a. So what I do is I try to find a way to factor out x minus a from g of x. So if I can figure it out so that g of x equals x minus a times something, and if I can make f of x equal an x minus a times something else, you see what happens if you can convert this problem into where these little punctuation symbols represent other functions that are not 0 at a. See how you can cancel this out? And why can you cancel out something in this case? Because we're saying we're not guaranteeing that the function exists at a. So this will never be 0, and this will never be 0. They'll get infinitely, well, they will get closer and closer without bound to a, but they will never be at a. Then you converted the problem into the limit as x approaches a of this quantity over this quantity, and no longer will there be a 0 in the denominator. This will hopefully be some finite or actual value. So that's the goal with this problem here. Since this is x minus 1, or x approaches 1, if we can factor out of the numerator and the denominator this factor, then we'll be good. If we can get them out of the numerator, let's factor the numerator. What is x squared minus x equal to? Well, by the distributive property, we could factor an x out because this has an x in it and this has an x in it. So here's x. Now, if you factor an x out of x squared, it goes down to just x minus. If you factor an x out of x, it just leaves x minus 1. There's the one we want to get at. So far we have this. This is equal to the limit as x approaches 1 of, see, replacing x squared minus x with x times x minus 1. And we still have this on the bottom. Still a problem because at 1, this is equal to 0. But how do we factor out an x minus 1 from this? Now is the point where we have to do some polynomial division. If you haven't seen that before, if you have seen that before, you know how to do it. If you don't, here's a quick review. We want to divide 2x squared plus 5x minus 7 divided by x minus 1, so that we can find out x minus 1 times what polynomial equals this polynomial. And if we can do this and have no remainder left over, then that will be good. The way to do this is you first look at the leading term with the highest order. This is 2x squared. And then you compare it to the leading term of this one, x. So I say to myself, x times what equals 2x squared? Well, there's going to be an x in there because x times x is x squared, and I need a 2. See, x times 2x is equal to 2x squared. So that means that this is what I'm going to put. And with this type of problem, you want to keep things aligned. It helps to make sure that you don't mess up and subtract something from which it ought not to be subtracted from. So I put this 2x in the x's column. Now that I've done that, I do a subtraction. Now 2x times x, as we figured out, is 2x squared. 2x times minus 1 is minus 2x. Okay, now we do a subtraction. It's a lot like integer long division. See, 2x squared minus 2x squared, 0. 5x minus negative 2x is the same as 5x plus 2x, which is 7x. And then we can just drop down the minus 7. Now, we need to figure out x times what equals 7x. That's pretty easy. X times 7 equals 7x. Positive 7, so we write a plus 7 right here. And now we have to do a subtraction. 7 times x is 7x. And we have to do it to the rest. 7 times negative 1 is negative 7. Now we have 7 minus negative 7. Negative 7. Okay, don't stop paying attention to this. Negative 7 minus negative 7. Negative 7 plus 7 is 0. And there's no more to do. We have a 0 remainder. So this is the answer. And now we can say that 2x squared plus 5x minus 7 is the same as x minus 1 times 2x plus 7. So we can replace this with this. So now it's the limit as x approaches 1 of x times x minus 1 over x minus 1 times 2x plus 7. And now, since we have an x minus 1 in the numerator and the denominator, we can cancel them out because you never evaluate a limit. You never compute what a limit is right at the value that it's approaching. So this leaves the limit as x approaches 1 of what's left, x over 2x plus 7. And now, since there's nothing that approaches an undefined value, we can plug in the target value right here. We can see what this function equals at 1. So this is 1 over 2 times 1 is 2. 2 plus 7 is 9. 1/9. So that means that the limit as x approaches 1 of this function, x squared minus x over 2x squared plus 5x minus 7, is 1/9. This one says find the limit if it exists. The limit as h approaches 0 of x plus h cubed minus x cubed over h. Do you know how to factor h out of the numerator and denominator? Because that's the only thing that's in the denominator. There's no more factoring you can do to the denominator. But we know that we need to get rid of it if we want to figure this out, because it's going towards 0 and it's undefined when h equals 0. Clearly we can't factor out an h from the numerator as is, because this term doesn't have an h in it to factor out. So what we have to do is expand the x plus h to the third. And if you know how to expand the binomial, then you know that it's time to do that. If you've never learned how to expand things of the form, for instance, a plus b to the nth power, where n is an integer, a positive integer, and these are two terms, let's look quickly at how to do that. I won't prove that this always works. I won't prove the theorem, but I'll just explain it, and you can use it. See how I start to draw a pyramid of ones, and everywhere past, I call this row 0, and I call this row 1. I call this row 2. Now you get it. Now everywhere for row 2 and beyond, I can take the diagonals and add them together. I call them the diagonal parents of this number. See how there's a 1 and a 1 right here? I add them together. This makes a 2. And then there's no more diagonal parents on the sides. This is row 3. Now look, here's a 1 and a 2. 1 plus 2 is 3. Here's the diagonal parents of this one. 2 plus 1 is 3. And then there's a 1. This is all we need so far, but just to show one more example, see if you can figure out what would go right here. What would go right here? 4, right? What would go right here? 6. And here, 4. And so from there on, you can see how to build out a row using this technique. So we've got this row number. If you're solving for a plus b to the nth power, where n is a positive integer, you use row n. This is the third, so we're going to use this row right here, 1, 3, 3, 1. Okay, I'm going to write that down right here, 1, 3, 3, 1. Now there's another thing to know. See these things? I'm going to work with the example right here. Let's say we're solving for x plus h to the third power. What I'm going to do is I'm going to write, for each one of these, there's 4 of them, right? I'm going to write x, h, x, h, x, h, x, h. Now, I'm going to put the number in front. But if it's a 1, I'm just going to leave it as is, because 1 times xh is just xh, right? And the fourth one, 1 times xh is just xh. But for the second one, 1, 2, the second one, I'm going to put a 3 here. The third one, I'm going to put a 3 here. So we've got xh, 3xh, 3xh, xh. There's one more thing to do, and that is I start with the row number 3. I start by putting a 3 on the x, the first one. Then I put a 2. Then I can put a 1 or just leave it as is. I'll go ahead and I'll put a 1. Okay, so the x has x to the third, x squared, x to the first, and x to the 0th. Now on the h factor, I'm going to start going the other way. 0, 1, 2, 3. And since there was a plus right here, I'm going to leave it plus. Why? Because it applies to the h. And you see how positive h is a positive. Positive h squared is positive. Positive h cubed is positive. And now everywhere there's a something to the 0th power, it's equal to 1. You know, x to the 0th equals 1 for all x not equal to 0, because 0 to the 0th power is undefined. But fortunately, we don't have any 0 values in here. If we did, it would be simply x to the third. So I can rewrite h to the 0th as 1, or just not write it. So this is x cubed plus 3x squared h, because h to the first is just h, plus 3x h squared, because x to the first is just x, plus x to the 0th is just 1, and h cubed. Now we have the expansion of x plus h cubed is equal to all this. So now I'm going to rewrite this limit, replacing this x plus h cubed with all of this. and then it's followed by minus x cubed all over h. And then you look at this and you see that there's a positive x cubed right here, and then there's a minus x cubed here, so they cancel out. You can see that solving limits often ends up in a lot of writing. Do you see what can be factored out of this numerator? You can factor out an h, right? Because each of these terms has an h in it. So I'm going to rewrite all of this as the limit as h approaches 0 of, now if I factor out an h from 3x squared h, that leaves 3x squared, plus, if I factor out an h out of 3x h squared, what's left? If you take an h out of this, 3xh, right? And if you factor out an h from h squared, what's left? Just 1h, right? And then the h in the numerator. Now you have a h in the numerator and the denominator. And now the problem looks like this. And now, for evaluating the limit, is there any problem? Does it become undefined if h is 0? No, it's okay to make h equal to 0 right now, because there's no more denominator with h's in it. Now, when h is 0, what happens to these two terms? Because they have an h in it, h is 0. What's 3x times 0? 0. So this term goes away and this term goes away. Look, there's no h here. So that means that the limit as h approaches 0 of 3x squared is 3x squared. So that would be the limit of this original problem as h approaches 0. This problem says find the slope of the tangent line at the given point. Now this function shown by the orange curve is f of x equals the square root of x. And the point where the tangent line just touches that curve is at 4, 2. So, you know the formula for a line, you know a point slope form of a line, which would fit because we have a point. So all we got to do is figure out the slope. The only problem is, you know the slope form is, let's say you have 2 points right here. And you want to find out this distance. And you want to find out this distance. Let's say this point right here was x1, y1. And this other point was x2, y2. The slope, which is often written as the letter m, is this difference in y values. You could write y2 minus y1 over this horizontal distance, which would be x2 minus x1. This would be great if we had another point that the tangent line is on, but by definition, the tangent is the line that only touches the function at a single point. So what do? Well, this is another application of limits. Let's suppose that we have another point on the line, and let's say its x-coordinate was some special x, and since this is the curve of square root of x, we know that its y value would be the square root of x. Now remember, this is not the tangent line because it's touching the line that connects this point right here, and this point is not the tangent line because it touches. See what I drew right here? I wish I had a different color of pen to distinguish. Let's write T right here because that means this is the tangent line. This line that passes through 4, 2, and x square root of x, this is called a secant line. Now, if you drew x closer to this point, and if you drew its point right here, then the secant line connecting the point of interest and this secant line, look, its slope is getting closer and closer and more approximating the tangent line. So instead of making a limit as x approaches some number, we can make a point approach the point of interest. What we can do is we can write the limit as x approaches 4. So that means that this x is going towards 4, but never really reaching it. And what is the slope of the secant line? What's the difference in vertical height between the moving point that you're sliding along the function curve? That would be square root of x minus 2, right? The distance right here is square root of x minus 2. How about the run of this triangle? That would be x minus 4, yeah? This will be the slope of the secant line. Now the limit, as the point approaches 4, 2, the secant line's slope would approach the tangent. But how do we solve this? Because look, if we plug in x equals 4, it blows up because 4 minus 4 is 0, and division by 0 is undefined. What can we do? What would you do? Do you know how to look at the numerator and the denominator and see any hints on how to factor something so that you can get x minus 4 out of the denominator? Think about special factors that you know, and if you don't know any special factors, there are an infinite number of unique factors to memorize, but you wouldn't want to memorize them all, but a certain few numbers are worth remembering. Here's something interesting that you might not have known. If you ever have a difference of squared, like a squared minus b squared, it has to be a difference, bear in mind. It turns out that an a squared minus a b squared is equivalent to a plus b times an a minus b. Now, if you do polynomial multiplication on this, you'll find that it works out to a squared minus b squared. Why do I mention this right now? Now, we don't have any squares in this, but if you don't see it already, what is the square root of x squared equal to? It's equal to x, right? And look, what is 2 squared? It's 4. So, I said the difference of squares formula. A squared minus b squared. It's the same as a plus b, a minus b. Okay? Well, what if I wrote this? I wrote down the square root of x squared minus the square root of 2 squared. Now, if you use this to convert this difference of squares into this, what do you get? What is this without the square? It's square root of x, right? Because there's an, if this is what we substitute for a, if this is what we substitute for a, now this one's pretty easy. What is the square root of 4 actually? It's 2, right? The square root of 4 is 2 because 2 squared is 4. And we put a plus here and a minus. So using this identity, we know that x minus 4 is the same as the square root of x plus 2 times the square root of x minus 2. So let's rewrite this using this instead of this. Okay, I'm going to erase the graph right now. So this is equal to the limit as x approaches, that's supposed to be an arrow, the square root of x minus 2, because that's what's up in the numerator. And instead of writing x minus 4, I'm going to write the square root of x plus 2 times the square root of x minus 2. And look at that. Now we have the same thing in the numerator and the denominator that we can cancel out. And what's left over is if there's nothing left up here, we just write a 1. And now we have the square root of x plus 2. And this one can be evaluated at 4. What's the square root of 4? 2. What's 2 plus 2? 4. What's 1 over 4? 1/4. So what does this mean? Let's get back to what it means. Remember, the function looked like this, and we cared about this one point, which was 4, 2. We wanted the tangent line. Now, because we used limits, we know that the slope of this line at this tangent line at this point The slope is 1/4. The point is 4,2. Now we can use the point slope form. Do you remember how to use the point slope form to give the equation for this line with this slope at this point? What does the point slope form looks like? It's y minus y1 equals the slope times x minus x1. Now in this case, m is equal to 1/4. The y1 is equal to 2. And then we have x minus, and what is the x1 in this case? 4, right? So this is the point slope equation of the line, of the tangent line, right at that point. Let's review what we had to do to solve this problem. First of all, we had to figure out, given this function, we drew a picture with the tangent line at that point. Then we found a x and square root of x point, and we computed the slope of the secant line, the limit as the point, the second point got closer and closer to the first point, and we used a difference of squares identity to factor the denominator so that we could figure out the slope at the point, and then we used the point slope equation of the line. Skills useful in solving this type of problem are the ability to use certain factoring identities, and also being able to figure out how to construct the type of equation that you want. This is a slope as a limit approaches. Yeah. So lots of practice will help you figure out what you need to do and how to do it. This problem says find the limit, if it exists, the limit as x approaches 5 of 3x squared minus 13x minus 10 over 2x squared minus 7x minus 15. One thing we can do is see if there's even a problem with the denominator becoming 0 at x equals 5. It probably will be, but we can just check that. 5 squared is 25. What's 2 times 25 is 50. 5 times 7 is 35. 50 minus 35 is 15, and then 15 minus 15 is 0. So we know that we have to factor out. What do we need to factor out? If the limit as x approaches 5 is what we're doing, then we need to factor out x minus 5 from 2x squared minus 7x minus 15. This is a good chance to practice on your polynomial division. So I look at 2x squared and I say x times what equals 2x squared? 2x, right? It's an x, so I put it above the x's term. I said 2x. Okay. 2x times x is 2x squared. Now, 2x times minus 5 is minus 10x. 2x squared minus 2x squared is 0. Minus 7x minus 10x is minus 7 plus 10 is 3x. And then we drop down the minus 15. Now I look at the leading term again, and I say x times what is 3x. That's easy. It's just 3 plus positive 3. Now, 3 times x. 3 times x is 3x. 3 times negative 5 is negative 15. Negative 15 minus negative 15 is negative 15 plus 15, which is 0. So that's good. That means that this denominator is the same as x minus 5 times 2x plus 3. Now, unfortunately, there's not already an x minus 5 for us in the numerator, so we also have to try to factor out an x minus 5 from 3x squared minus 13x minus 10. So what do we have to do first? X times what is 3x squared? X times what is 3x squared? It would be 3x, right? That goes in the x's column. So x times, I'm going to do this. X times 3x is 3x squared. 3x times minus 5 is minus 15x. 3x squared minus 3x squared is 0. Negative 13 minus negative 15 is negative 13 plus 15, which is 2x. And we drop down the minus 10. So x times what is 2x? Just a positive 2. Okay. 2 times x is 2x. 2 times negative 5 is negative 10. 2x minus 2x is 0. Negative 10 minus negative 10 is negative 10 plus 10, which is 0. So that means that the numerator is x minus 5 times 3x plus 2. All right. So we can write this whole thing as the limit as x approaches 5 of x minus 5 times 3x plus 2 over x minus 5 times 2x plus 3. And these troublesome x minus 5s get canceled out. So this is the limit as x approaches 5 of 3x plus 2 over 2x plus 3. And as we can see, making x equal to 5 does not cause a problem anymore. So we can just plug it in. What's 3 times 5 is 15, plus 2 is 17. 2 times 5 is 10, plus 2 is 13. Yes? So the limit in this case is 17/13. This problem says find the equation of the line tangent to f of x at the given point. And the function is f of x equals x to the minus second power. And the point is 2 1/4. Do you have in mind a strategy for how to solve this one? You remember how the previous problem was solved? Well, what I do usually is I want to draw a picture so I can visualize what's going on. First of all, x to the minus second is the same as 1 over x squared. So we know that x squared looks like this. And if we invert that, it'll look like this. And we have 2 and 1/4. Let's say that this is 1, and this is 2, and this is 1/4. This is 2. So the tangent line is going to be the line that just touches the curve at this point. So it's going to be glancing off of the curve like that. So we have a point. We want what? We want the slope of the tangent line. But we don't have 2 points on a tangent line. Do you remember the technique used? Let's say we pick another point. We call it X. And this would be, let's use a different letter because the function is already, these are all X values. Let's say this is A, and it's going to be a to the minus 2. So this other point right here is going to be at a and a to the minus 2. And the line connecting the point 2, 1/4, and a to the minus 2 is the secant line. And do you remember the technique? As the limit, as a approaches 2, as a gets closer and closer to 2, these secant lines will get closer and closer to the true tangent line. So let's say that this is the distance. What is this point? A to the minus 2nd. This point right here is 2 and 2, 1/4. What is this? It's the difference in y values, or the difference in second number values. So we can write a to the minus 2 minus 1/4, right? And what is this? A minus 2. Now we have 2 points. We can find the slope of this, can't we? The slope is the difference in the change in height over the change in horizontal distance. Okay? And as a gets closer and closer to 2, the slope of the tangent line will be the limit as a approaches 2 of a to the minus 2 minus 1/4 over a minus 2. So, how do we solve this one? Think about this. How do you handle the difference of squares? Can we write this? Is 1/4 the same as 2 to the minus 2? Yes. But now what do? We don't know an identity for differences of inverse squares. We know a formula for difference of squares. Think about this for a while. Pause the video and think about this. Have you thought about this for a while? Okay, here's an idea. Now we can rewrite this as the limit as a approaches 2. Now, a to the minus 2 is the same thing as 1 over a to the second. And minus 2 to the minus 2. 2 to the minus 2 is the same thing as 1 over 2 squared, which is 1 over 2 squared. And all of this over a minus 2. Yes? Now we can combine these fractions. The limit as a approaches 2. What do we have here? 2 squared minus a squared over, what's a squared times 2 squared is 4a squared. 4a squared. This is all of this. And in the denominator is a minus 2. This may look very messy at this point, but we can bring this up into the denominator right here. So this is the limit as a approaches 2 of 2 squared minus a squared over 4a squared times a minus 2. Now we have a distance of squares that we can do something with. But in advance, I noticed that I want a squared minus 2 squared. So what I'm going to do is I'm going to flip this around and put a negative sign in front. So we have the limit as a approaches 2 of minus a squared minus 2 squared over 4a squared a minus 2. Okay. Now remember the difference of squares identity? What is a squared minus 2 squared equivalent to? It's the limit as a approaches 2 of minus a plus 2, a minus 2, over 4a squared times a minus 2. And finally, by turning this into a difference of fractions and combining the fractions and proceeding from there, we finally can cancel out this a minus 2, which leaves us with, let me erase some things up here. The limit as a approaches 2 of minus a plus 2 over 4a squared. And now, since making a equal to 2 doesn't cause a problem, we can solve this limit at a equals 2, supposing that our second point has approached all the way to this point. Now, 2 plus 2 is 4. So we'll get the minus 4 over 2 squared is 4. 4 times 4 is 16. Minus 4/16 equals minus 1/4. So this is the calculated slope at the tangent. We did that using limits. So if m equals negative 1/4, as we can see, the slope is a negative slope. And if the point x1, y1 is 2 1/4, we can use the point slope form. Do you remember the point slope form? Y minus y1 equals m times x minus x1. Okay, so then it's the slope, the equation for the tangent line is y minus 1/4 equals negative 1/4 times x minus 2. That's the equation in point slope form of the line tangent to x to the minus 2 at 2 1/4. The key part was noticing how to figure out how to get this right. And the turning point was turning it into a fraction. So you have to sometimes be creative and see what you can convert things into to factor out the factor that you need.